Hello, so back again. This video, as all of them, is sponsored by Autodesk. I need to say that, so I get that in at the start. I've made two spheres here, pretty much like, oh, hang on a minute, lack of Maya skills. So there's that one and that one. They're different topology, and I'm going to be doing something similar to that I did last time, which is using this one to read data from the other one that's underneath it, that color map thing that's there, and but using a different method to do it. So last time we used get closest locations, and this time we're going to be using the other, what are called geometry queries. So if I bring this in, I'll bring them both in, so bring that one in and bring, my pen's acting weird, get rid of that. So read ball is the one that we're reading from, sorry, we're reading from the one with the colour map ball on. I don't know if read ball was the best name, probably write ball would be better. But anyway, we're reading from this one, colour map ball sphere, which is the one underneath it. So last time we used, if you go here, geometry query, and we used get closest locations. But this time we're going to be using, first of all, get raycast locations, because it's probably the most. No, it's not actually. No, I'll do the other one. Do get. Where is it? Get closest point. This one works pretty much the same as get closest locations, but instead of finding any spot on the surface, any closest location on the surface, this one gets the very closest point and finds the values on it. So it's quite similar to the original one, and it doesn't look a lot different, the results really. Let me, so I'm going to get point position, get point position. I feed that into there. We'll get closest point, and then we have to get the sample property and feed the locations into there. The geometry is still this one. We want to get the, we're sampling this. The default we have to fix to a, what are we looking for? It's a math float 4 because it's an RGBA, so it's 4 values. And the property we're looking for is the color map on this one, which I think I called it Paul. I'm just checking in here. Paul, yeah. So property Paul. It does matter about capitalization, as far as I can tell. So that's something that's worth thinking about. So on the sample data, then we can get a push deformer, which I made in an early video. Stick that into there. Oops. Mesh into there. Then the push positions we need to do. Then set point position and do the output there, and then that's going to make a BIF object. And it's not doing anything. Oh, because I bypassed that, sorry. That's got to go into there, and then that's got to go into there. And that still doesn't work. So that's interesting. Why doesn't it work? If I hold my mouse over there, the cursor, you can read at the bottom of the screen. When combining blah 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 blah, no promotion exists from type value array, math float 4 type of array, math float 3. Ah, okay. So I forgot to do that thing where this is 4 values coming out of here, and the this accepts a 3 value, so we need to, or a single value rather. So we need to change that from a vector 4. This, look down here, 0 0 0 0 to just a single value. So I go vector 4 to scalar, and that splits it up into its component parts, which it says X, Y, Z, W, but it would be RGBA. I mean, you know, they're just values, but that's, you know, it was originally RGBA thing. But they're just numbers, basically, so it doesn't really matter what they're called. So if I use the X, we're going to get that B poking out. Let's move the BIF to the right, just to sort of... Sorry, not the B, the R. That's the R. And G would be there. And B would be there, which relates to those, oops, those there. The normals are looking weird because we haven't updated them, so let me stick that in. Update mesh normals, and I need to stick that between that one and that one. Then it should look a bit more natural. Yeah. Now, the closest point is very similar to the closest locations, but it's just getting one point, the closest point from the read ball, which is here, and it's finding the closest point on this one, which is the one with the color map on. So that's what that one does. Let's go and try a different one now. So go back down here, geometry, query, get raycast locations. So let's use that one instead. So let's delete that get closest point. And raycast locations takes a positions, which is, you know, just the point positions. If we're doing this on a mesh like this, we're reading from that bit of geometry there. Let me zoom in a bit so you can see it. So we're reading from, again, from that one, but it also takes directions, because what it does basically is fires out little rays from here, from these positions, which are all the point positions, and it also needs a direction to fire the ray out in. So for that, we're going to use get point normals, because, you know, that probably makes the most sense. I think I said before, I've made that get point normal node, but actually, you won't have that. You'll just get point normal, which is actually identical, but I'm going to use the factory default one. And the normals fire there, and the locations go into there, and the geometry goes into there, and the default and everything is just the same. So, okay, nothing's happening at the moment, and that's what we'd expect, because this object here, this read ball, is bigger than the color map ball, and the normals are pointing outwards, so none of those rays are actually hitting the ball. If I shrunk this down, this object down, you'll see now that now it's inside it, its rays are obviously going to hit the one that's outside it, which is now the color map ball. So that's what's happening there. And that's what raycast does. It fires little rays out from the positions that are dictated here in the direction that's dictated here, and whatever it hits, you know, then it picks up and samples whatever. And then we decided to sample this map called Paul, splitting that up into its component parts and using whichever one of them, like that one, or that one, to then drive a push deformer. So hopefully that makes sense. Now the other one is a bit more complicated. Let's have a look. It's geometry, query, and it's get points in radius. Okay, now the reason why this one is more complicated is because this one here isn't just going to return one point like that closest point would do. This one is going to return all of the points that are within a certain radius. So it might return like 20 points. And if we want to then use those 20 points to drive a value, obviously we're going to get 20 values hit. We're going to sample 20 values. So you can't use 20 values to drive one single push deformer. So then you have to choose whether you use an average of them, or the largest value, or value number 30 out of that array or that list. You have to do something to them afterwards. And because this is a list, remember the point positions are also a list. So this is a list. This would be, you get a list of point positions, and each point position has its own list of points that it's found within the radius. So that would be like a 2D array. And to deal with that sort of stuff, you have to do a thing called a loop, which if you know anything about programming, you probably already know that. But oh, I've got an order. Let's get rid of that. So what the loops that are available, well, the loop that I'm going to use in here is a for each. And what that does is it does something for each of these. So for each point position, and there might be like 300 point positions, don't need point normal for this, we're going to do something. And so what we're going to do is we're going to get these two and we're going to stick them inside there. So I'll double click on that, and anything that happens in here happens for each point in the object, or for each value in this array of things. So I go in there, let's get this. So I'll get rid of that one, paste it in there. So each point is going to get the points within the radius. Oops, sorry. We can pick the radius, let's say 0.2 over here. The geometry we're also going to need to get into this, so I'm going to need to go like there, and we'll be able to see that output there, geometry. So we're going to stick that there. Let's go back inside by double clicking on it. So we're going to put that in there, the geometry there. The property is still Paul. I don't know why that's, hang on, let's just read this. No promotion exists from value of type array to a value of type array. I don't know what that means yet, but let's carry on. And it might be because I need to change, I don't know, let's just carry on. We don't need that port, we don't need that port for this. We just need those two as the input. We're going to then get a vector4 to scalar. And now, once we've got this, we need to this is going to be returning a value for every single point in the radius of that this is finding. So we need to let's get the average of that. So in ICE you'd get just a get array average node, but here you have to make your own. So to do that, you get the sum of the array, which is all of the values added up together, and you divide it by the amount in the array. So we need to get the array sum, sorry, not the array sum, array size. The array size tells us how many values are in that array, and we divide that by the array size. Okay, and we need to change this value to a float, which is this same type. So I get 2 float, because that's an integer, and that's not going to work. So we do that and that, then we do that as an output. And then we plug that output into there, and it's errored, which is sort of what I thought it would do. Right, let me work out why. Now, I think it's because this default isn't an array, but I'm not entirely convinced about that. So let's see if we can do this. Let's create a value node, and let's go into that and make that an array. No. Okay. Okay, let's go out of it again. Point position going in, for each thing, do that. Go into it, we're getting the points in the radius. Sampling the property. geometry in there. I'm going to pause it because I don't know what's going on here. Okay, I've figured it out. Doesn't make complete sense to me, but it was something to do with this. Basically, when I started a new one of these and then just deleted that one and then plugged that one in, it worked. It doesn't. Okay, all right, let's try that again. Okay, let me try that this way around. Let me plug the point position into a new one and then delete that one and then go in and get the point position, plug it into there. Okay, that works. I'll have to investigate why that works, but it may be something to do with these types. If they're made in a certain way originally, they can't just accept a new type or something like that. I don't know. Anyway, I'm still learning, but hopefully now this is kind of doing something. It's getting the points in the radius. It's then sampling all of those points. I'm then array averaging them with this thing, which I can make a compound to do that. Let's do that actually. Call that array average, and I'll actually publish that. So publish. Yay. So that's a useful node. Now I'll go back out again and okay, it's not doing anything to the mesh though, which is slightly weird. Why isn't that doing anything? Okay, let's have a look at what I've done wrong. Value, sample property, point position, we don't want that, we want pool. Okay, brilliant. That's what we wanted. So now it's reading that pool, which is the color map value. The reason why it's all blobby and weird like that is because we are getting an average of all of those values around that area. So if you look in this node, we're getting points in radius. Oh, sorry, I keep doing that. A radius of 0.2. If we make that smaller, say 0.05, it will be sharper. And if we made that higher, like 0.5, it's going to be really blurry, because it's reading all of the color values that have, say, are green. You know, each point is reading, say, 50 points and getting the average of all of those. So obviously if you're making that amount tighter and smaller, okay. Now the reason it's doing that is because it's not getting some values at all in certain areas. That's too small, that value, 0.1. I don't know why it makes it disappear, but as this amount gets higher, say 3, it's getting more and more blurry. 0.2, because of that, because it's getting a bunch of points and reading the average. Yeah. Anyway, that's an introduction, not a very good one, so that went wrong. But I think it's valuable for me to show when I go wrong. To these loops. So let me just recap. So we got, from this mesh, we're getting all of the point positions, the sort of however many it is, 600 points or whatever. Each of these 600 points is coming as a list of points from here to here. So it's an array of points. Then inside here, for each point, literally, and let's go inside, each point is now getting the points from the other object within a radius that I dictate here. It's returning, say, let's say it returned 20 points. We're sampling the property of the color map here, which is named pool. We're changing that into its RGB values. We're getting 20, say, green values of this one coming through here. we're getting the average of them because we can't set one value with 20 values. So we're getting the average of this 20 values and we're outputting it. So that's here, this output. And then we're using that to drive the push deformer. And we're doing the rest as normal. So that's what's happening here. Yeah, I'll leave it there. Apologies if this one's is confusing. I will deal a lot more with arrays in the future. But yeah, I'm still figuring it out myself. But I do sort of quite like the fact that it deals with them in this way, where you can just go inside and deal with stuff inside the array and do it for each value. It's slightly different to the way ICE worked, and but what I quite like about this is that I think you could just go inside, you know, say this was an array here, well, which that, you know, array here, you could do another for each inside that, and then go down, you know, inside levels of arrays and do stuff to it, which you couldn't really do it in ICE in such a kind of standardized way. ICE had things called contexts and, oh, I'm waffling. Anyway, yeah, that's an introduction to arrays. All right, cheers, thank you, bye-bye.